Welcome everyone to today's video. For today's video, we're going to be talking about distance and displacement when it comes to describing the motion of an object as it moves from one position to another. Let's go ahead and dive right in. Okay, first we'll define distance when it comes to describing the motion of an object. And in physics, or at least when describing motion, distance is a scalar quantity describing how much ground an object has covered. And this is regardless of direction. That's what scalar means when we're talking about a scalar quantity. It's just a measurement that doesn't take into account the direction of anything. So like degrees Celsius, calories eaten, miles per hour, in any direction, it doesn't matter. To kind of show an example of how we would calculate the distance of an object here, just for the sake of doing it properly, we have a person here over at position A, and this person's going to run all the way over to position B and then run back to C. This is just a random example. So from position A to position B is 5 plus 6 meters. We'll go 5 meters plus 6 meters. And then that person runs from position B to position C, and that is that same 6 meters. So we'll go plus 6 meters again, and that's just 5 plus 6, 11 plus 6 more is 17. Hope that's right. Mental math. So this person started here and ended here, and in the process of this person's movement covered a distance of 17 meters. Let's go ahead and talk about displacement. Okay, when we talk about displacement, we are talking about a vector quantity that describes how much an object has changed its original position. So the difference between that and distance is, when we're talking about distance, it's the total ground that an object has covered during its motion. But when we talk about displacement, it takes into account just its change from its original position. And vector quantity, displacement is a vector quantity, which a vector quantity just means that it has a direction involved. So when we're talking about the motion of objects, it's not just this object covered a ground of 17 meters. It's this object moved from its original starting position in a particular direction. And that's what makes a vector quantity different from a scalar quantity, and displacement different from distance, in that there's a direction involved. So when we go to take into account this person's motion, and we're describing his displacement from his original starting position, or whatever, it's a stick figure, we only want to know the starting and end point. So it started at position A, ended at position C, so we just need to know that distance from A to C, and it's just 5 meters, and that would be that object's displacement, this person's displacement. Now, we don't have any directionality here, so we would just say from our viewpoint looking down here, this was 5 meters right, or rightwards. This person just moved to the right 5 meters. Whereas distance, we would take into account the entire motion of it, and it doesn't matter where he ended up, where the person ended up. Let's go ahead and look at a couple examples just to kind of hammer this home. Okay, going with the track references when we're discussing distance versus displacement, and we're just going to do a couple examples here to kind of break it down a little bit further. So a person's running a lap around a track over at a local track and field place. The distance around this track is 400 meters. That is the total circumference of the track. So the distance this person would cover on this track would be a total of 400 meters if he ran just one lap. His displacement is going to be the change in their original starting position, and since they all start at the starting line, we're assuming they all started from the same spot and finished at that starting line again, their displacement, even after running that 400 meters, would still be 0 here at this point, because they started and finished at the same spot. That is, there was no movement from that person's original starting position. Let's go ahead and look at one more example. Okay, last example we'll look at, just describing distance versus displacement. So in the previous example, we talked about how this person ran a full lap around the track, starting and finishing at the same spot, and that was about 400 meters was the distance around the entire track. But since they started and finished in the same spot, that did not change that object's position, that person's position, so they did not have any displacement. It was a zero displacement. In this case, though, in this example, we're just looking at another track reference. A person is running the 100-meter dash, and they start over on one length of the track. They sprint over to the other, finish 100 meters on the other end of the track. This was their starting position. This was their finish. The total distance between the start and finish was 100 meters. And in this case, the displacement will also be 100 meters because this person started here and then finished over on a position that was 100 meters away from his starting position, his or her starting position. That's all there is to distance and displacement. I hope you found this helpful. If you did, please like and subscribe, and I'll see you guys in the next one.